A very good morning and good evening, everyone. Welcome back. Just switch the network. Okay. Yeah. All right. So last session, we were discussing about some Linux commands. We talked about started talking some additional things that, what you can do as a basic. So additionally, like we wanted to see like list of process which is running and how do you stop it's not a stop, how do you kill your process? Like, so remove your process, right? So kill the process because there is a stop process concept also is there. Okay, so that means you can stop and resume. Okay, pause and resume. That concept is also there. So we're not talking about that. So essentially, so completely kill the process. Okay, and after that, so we talked about the user management. So user management, we wanted to add a user in the context of adding a user for the application because the application need to run that user. So that's where the user add command. And the next is user add. And after that, we talked about the package management by using DNF command. So until here, we have discussed in yesterday's session. Any questions on this before proceeding until now? Okay, cool. So the next one, which we're going to talk about is a service management. Okay. Now server is all about running some services. Okay, that runs 24/7, correct? And which essentially means we need to know about how do we manage our services, right? So that is where the service management will come into picture. Now services that runs as a process, services are also the process, okay, but that runs in the background. Now previously or not previously, all the time the commands we are running is a foreground process. That means you run in the foreground. Okay, so that means now the sleep command, if I give 10 seconds, I will not get the prompt until that command is completed. So it can be any command. It took some time or it took all the time. So that means like it will run 24/7 in the background. So now I wanted to push this particular process to the background. So I want this prompt immediately. So then we'll do the ampersand by the way. Okay, so that it will push to the background. Okay, and immediately you get the prompt by the way. So there's a background process. ps-ef for sleep. This is also still running, but running in the background. But just imagine, okay, I want to run a service, let's say a Java service I wanted to run. And I started by using Java. Uh, I just started using a background. I push that particular Java service and the Java service is running very well. But however, I want to stop the Java process. Then I have to go and find the process and I have to kill the process. And I want to start it again. Maybe I have to go into that directory. I have to remember the command and execute it. Probably some reason I rebooted my server. Okay, for any reason, for maintenance or whatever it is, I restarted my server. So then again, I had to go and start the server. Okay, there is a lot of operational work which is involved here. So that's where every operating system has its own every operating system have its own service management. Even Windows also have that. So Windows services management, something is there. Okay. So you will be able to see the list of services, something like this, a service manager. So not sure this diagram is quite visible to you. So here you can go to the services, you can right click, start, stop, all those particular things you can do. Okay. So you can just go, this is a process, not service. But yeah, so the overall point is you can always, this one is the right diagram. So you can just go here, right click the service, you can stop the service, you can start the service. Okay, these things you can do. Same like Linux also have is service management, and the service management is to run the process all the time in the behind, and that's where so to start it, stop it, manage it at the time of reboot. For these requirements, you have a service management which is available, and in modern systems, by the way, it uses systemd. I think systemd was introduced in RHEL 7. Okay, so it was init.d in the old system. So from RHEL 7 onwards, um, from RHEL 7 onwards, it is systemd. Now, the systemd is a program that actually manages your services. And to manage the programs, you have a systemctl command. The command you have is systemctl. Okay. Now, systemctl, sudo systemctl. This is also an admin activity. Now you can give status of any service. Okay. For an example, we are connecting to the server over some service, which is SSH. I can go and give SSHD. So what it is telling is, it is giving you that it is running, okay, running from what time, okay, blah, 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 some information it is giving, right? Display the current status. And I'm pressing Q to come out. Okay, it is not giving me the prompt. If I press Q, I will come out. Now systemctl start of that service. If any service you need to start, you can go and start the service. So for an example, sudo dnf install nginx. So let that package install. Okay, I just installed the software. This also comes with a service. Okay, it's also a web server. So I'm just taking this one. Sudo systemctl status nginx. So now you can see this, it is actually inactive. It is not running. Okay. Now what I will tell is sudo systemctl start nginx. So that will start the service. Okay. Now you can go and check systemctl status nginx. So now you can see that it is running. Now you can go and give stop the service. So stop nginx. So then you're going to stop the service. So status nginx. So you can see this again, it is inactive, by the way, right? Now, sometimes you need to restart the service. Restarts comes like sometimes you update a configuration. Okay. So you need to go for a restart or something like that. So then you go for restart. Okay. It just does the restart. Okay. This is simple service management. And now let's say, first of all, I don't know what all the services I have in the worst case. Usually you'll not get into that scenario because you know what you're managing in that server. But in the worst case, like let's say, hey, I don't know what is really running on the server. Now sudo systemctl, okay, list hyphen units. It can list many, but we can ask for the type is a service type and enter. So it just tells me what all the services which I have here. Out of that, Nginx is also one of that. Okay. So Q2 come out. Now the last but not least option, so systemctl status nginx. So now you can see this. So there is a preset is disabled and also the current service state is also disabled. What is this disabled, by the way? What is the purpose of this? Now, this is nothing but the enable status during the boot time. So during the boot time, so now let's say I recreate, I mean, restarted this server. Okay, for whatever the reason it is, I rebooted this machine. So now during the boot time, whether I wanted to start the service or not, okay, the vendor is telling that by default I'll not enable, but you can override the vendor preset value by enabling in your system, by the way. So this is from the shipped software status. This is from your system perspective. So we always need to bother about the system perspective. Now, if I go and give system CTL, now the current status is running, right? Now I'll go for a reboot, sudo reboot. Reboot is a command that will take to restart your server. Okay, the machine could have been rebooted now, reconnect. Okay, now if I go and give systemctl status nginx, so this is not started. Now during boot time, so even I wanted to start my service automatically. So then what do I do? Sudo systemctl enable nginx. Now the moment I enable nginx, so if I go for the status, so it tells me that it is enabled now. So even though it is dead or whatever the reason it is, now sudo reboot. Okay, at the time of boot time, now you're telling to the system D that you start this service automatically, so that it will start the service automatically. Okay. So after once the system is up, so you will see that the service is started automatically. So let's wait for this. Okay. Now the before rebooting, by the way, the service was not running even. So, but it is enabled. So that means what happens? Sudo systemctl nginx. Now you can see this, it is running. So how come it was running? Because we have made it as enabled. All right, so this is how we can do that. Now, what we have done is we have installed a package, and that come with its own service. But in the organization, maybe okay, the service was developed within your company. Okay, you may not get all the service files and all. So ideally, like if I need to write my own custom service, then you can still do that. So all the service files, you'll find it out in this particular location. So if you go into cd etc systemd system and do ls, you'll find out so a lot of service files so inside each and every directory. So or else you can directly create here also, it's okay. So like for an example, multi-user target is a place where you have many of the services coming. So even nginx.service is also there. Okay, or else I can directly keep it here to work. Now, what all I need to do is, it's a very common standard, by the way. So you can find in the internet that how do you create your service file. So for an example is like, let's say sample systemd service file. Okay, so this is the bare minimum standard. Now you got it. Then just go into the system. Sudo vi sample.service file. Okay. Now sample.service file. Now you have to write some information. So this is my custom service. It's okay. After is always network.target view. So that means after network, you start the service. The service is very simple service. And what I'm going to do is I will just give slash bin slash sleep. Now let's say something I'll give. Now on failure, like let's say, I mean, you just restart. If this process actually has been completed successfully, no issues. Or if it failed, so then you just restart it, is what you're telling. And yesterday we were talking about, even though we use, so now let's say sudo user add sample or demo user, for an example, or even I forget to give shell slash bin slash sbin slash no login, and I'll give the, like let's say sample user. Okay, I created the sample. So cat slash etc sorry, password etc etc password file. Okay, so here this user doesn't have login. Now su hyphen sample, so that sudo su hyphen sample. Okay, so here we have sudo su hyphen sample, and then account, it is telling it is not there, right? So that's where what is the thing we're talking about. So now how do we still use this user to run here? Now this is, sorry, user is equal to sample. Okay, sudo. Now, since I loaded a service, I have to tell to the system that I have to, I please you load that. So that's where what we're going to do is, so daemon reload, sudo systemctl daemon hyphen reload. So you will tell that, hey, I am adding, I'm adding a new service. Okay, you just reload. So you got it. Now sudo systemctl status sample, if you give, you can see that it is not running. And the sudo systemctl start sample service, because the file name is sample.service. So that means the service name is sample only. Okay. Now you can go and give status for that. So now you'll be able to see that it is running, it is active, and it is started a process sleep. Now that means essentially it is end of the day, it's a process only. When you have grep sleep, but who start, how do you start is what is the matter. Okay. So this is how we are going to deal with our services. All right. So what all we have learned, by the way. So there is a service management. There's a service management. Um, I mean, software which is already available in the operating system. We're just going to use that. By using that, you will get certain advantages. So what are the advantages? At any point of time, the system went down. Okay, I can start it automatically. Or if I need to start, I mean, I need to shut down and start up the services. It is easy for me to do that. And also it gives you flexibility to add your own services. Okay, so we just added the service. And what are the program I have? I just executed a demo program, which is sample. It can be a Java program, it can be a Python program, or whatever it is supposed to run. So we will use it and run it. And it is customizable. And even you're seeing some features like, on failure, let's say if for any reason that program crashed, so then the system D will observe that, automatically start the service also. It has a hell lot of features also. Okay, so that's where we always rely on the system D for the better practices or the best practices, by the way. Okay, so that's about something on the service management. So overall, systemctl command is a command. Status stop, restart is a major one, and enable to start the time at the time of reboot. And sometimes when you add your own service, you always make sure you do a daemon reload so that do the daemon reload so that it just reloads the service. Okay. Yeah, that's about something on the system D. Any questions?
Currently, we are running it as a single user, right? So if we want to provide it for a multiple user to run, so can we do that over there?
No, none of the. It is always a single user, right? So you can't. Little illogical in any operating system. A program needs to be associated to a single user only by design. You can't associate a process to multiple users. So that's where there is no point in giving it to multiple users. If you need to do it, so you go and update the service file and restart the service so that it will start that with another user.
Thanks.
Yeah.
Yeah, Raghu. So in this sample service, did we add the sleep, whatever that, 10,000?
Correct.
Okay. Oh, okay.
Any other questions? Okay, cool. So that comes to the um, next topic. So which is how do you deal with the permissions and ownerships of a file? Okay. So how do you deal with the file? And I mean, how do you, when I say deal, by the way, so how do you deal with the ownership of that particular file and permissions of that particular file? So when you create any file, for an example, so if I create a touch sample.txt, now ls-l, so you can see that it is giving the permission or ownership as by default, which is ec2-user and ec2-user. So because I am the user, which is ec2-user, I belong to a group called as ec2-user. So that's where it is telling. So who is the owner and who is the group owner for this particular file? Now, in a case, if any case, by the way, I want to change the ownerships, by the way, so then you have commands here. Okay. So you have chown and the chgrp. To change the ownership, you have chown command. So sudo chown, and if I try to do normally, it won't allow me. So chown to, like, let's say sample user to the sample.txt file. So it tells operation not permitted. So sudo. Now ls-l, so you see that that file has been transferred from ec2-user to sample user now. Now, the same way you wanted to change that to a group also. Now, let's say group is demo, grp. To demo group, I wanted to give ls-l and sample.txt. So I have given this file ownership to um, a demo directory. It's a demo group. Okay. Now, the same thing can also be applied to a directories also. So you already know that in cp command or rm command you have learned R option. So here also you'll use the same option, but capital R recursive if it is a directory. Okay. So we'll use -r if it is a directory. So that's how you can change the ownership and group ownership. But however, rather than executing two times, if you have a requirement of changing the ownership and group at once, then what you can do is, so you can go for chown only and ec2-user colon ec2-user, and you go for sample.txt. So which means both has been done at once. So ls-l of sample.txt. So you can see that it is EC2-user and EC2-user. So the CHOWN it itself can take care of both the group and ownership at a time. Group and normal ownership at a time. So this is how you will do it. But by doing this, what do you achieve, by the way? So that is a essential important one. And so that is going to be coming to file permissions. Now, being a owner, what you can do, being a group owner, what you can do. Okay, so that's where is the permissions coming into picture. And the first block tells you, okay, about the permissions. Now, the first character of the first block is tells you the type of the file. We already discussed in the files in the maybe in the first session or second session. So we talked about the types of files. Whereas if the first character of the ls-l is going to tell us what type of file it is. If it is a hyphen, it is going to be a regular file. If it is a D, it is going to be directory. So this is what we have learned, right? So that means out of this block, so for the first character, you can ignore. And which is the next one. Next 9 characters is the permissions here. What is this things are telling? So here you have RWX. RWX. Read, write, execute. Okay. R stands for read, write stands for W stands for write, and X stands for execute. Okay. Now, if you have a read content, you can view the content of the file. So that means the EC2-user. So these are the 3 blocks, by the way. Now again, we need to cut into 3 pieces. The first 3 characters, second 3 characters, first third 3 characters. Now, what is this guy will do? Who is the owner? What he can perform? So that is the first block. And who is a group owner? So who is the part of this particular group? Users part of this particular group. What they can do. Now, this is an operating system where you have not only the EC2 user and the EC2 group, there are other users and other groups are also there, right? So how do you deal with this? Okay, so are those what can do is this permission. Not only this owner, this user and this group, the system has other users and other groups. So what they should do it. That's where is this permission, others. So which is owner, group, and others, we call it up. Okay. So what is this permission is telling? Whereas the owner can read and write. So that means view the content and modify the content. And whereas the group owners, like, that means like, people in that group only does the read. And whereas the others also can do a read on this particular file is what you're telling. Okay. So now how do you would like to modify that? So the owner will be given as a U, a short character, and group is G, and O is others. So now the command that comes into picture to modify this particular one is sudo chmod. Okay, so you can give U plus X, that means user plus executable permission to that file. So that means if I go and give sudo chmod U plus X and then sample.txt. Now, if I do ls-l of sample.txt, so you will see that there is a executable permission also, which is involved. Okay. So you got the executable. So that means you can execute this file. The next is let's say group people doesn't want any permission. So G minus W. So others you want to add a read permission, something like that. I want to give everyone every permission. So ch okay mod. So all people, so that means UGO altogether, what is the permission they want? RWX sample.txt. So everyone, every permission you have provided. Now you don't want to provide anyone any permission. Okay. So sudo chmod. Okay. So UGO minus RWX, which is sample.txt. Okay, so ls-l and then sample.txt. So you can see that no one have any permissions. Okay, so usually in systems also there will be some files like, so sudo ls-l/etc. Let's say you'll find out some files where none of the users will have none of the permissions also, some files. Okay, some critical files will be there where no user will not have any permissions. Okay, so this is what is we have. Okay, so that is what we have. And alternatively, so there's a numeric method also is there, so to provide the permissions like chmod 755. So to calculate that, so 7 is stands for read write execute, and 6 stands for read write. So rather than this, if you are starting fresh, I would suggest to go with this approach. UGO, easy to understand, plus or minus. Plus means adding permission, minus means remove permissions. Plus or minus RWX you are doing, so that your permissions can be provided better. Easy to understand. So the same thing applies to chmod also. If you are performing things to a directory, you can give -R option to do it for a directory. But the permission wise, this is what we have in the permissions segment. So to change the ownership, chown command. To change the group, chgrp. If you want to change both at the same time, so chown can handle, and whereas chmod to change the permissions of that particular file. Okay, so this is essential. And so that's all on this particular topic. But however, I would give you some extra reading topic for you whenever you get some time. So special permissions in Linux. So there are 3 special permissions which are available, but where there are they are not too much regular, okay, to use for a normal user. But for administrative perspective, okay, so these are certain interesting things. Okay, so whenever you get some time, I would suggest you to okay. So just from the learning perspective, whenever you get some time, okay, so I usually put it in the name of backlog. Whenever you get some time, you just take care of reading, okay, sometime one day. Yeah, so that's about some permissions. Any questions on this?
Hey Raghu, so only generic files can be manipulated, or it's same for all the files types?
It is for say every file. I mean, the ownership and permission is applicable to, same concept is applicable to all the files.
Thank you.
Any other questions? Okay. So that comes to the next one, which is a disk management. So your server have certain disk, by the way. So generally, like, so if it is a database server or something like that, usually you'll see high disk. And if it is a stateless application, okay, so which doesn't store any data, okay, you'll usually find less storage to that servers, okay, kind of a thing. But whatever it is, if how many hard disks I have, and okay, so how many are being used, how many partitions are there, something like that, just need some essential information. Now, same like, okay, so C drive, D drive, something like that. So C drive in the operating system in your Windows is nothing but your partition showing, or it can be a separate hard disk also, right? Okay, when you put a pen drive, so that means a new hard disk will come. So that means it itself is a completely new one also, right? So which means um, um, here, okay, that I mean that terminology basically we call it as a mounted, okay, mounted disks, by the way. Now here also we will come to I mean we wanted to see the list of mounted disks on our system. So there is something called as df-h. Df command will help you in understanding. So what is the disk name and which directory it is mounted to. Okay. Now the disks names, if you look back, by the way, the disk names has been started in this approach. So old, if you get into the old way, so there is a PATA disks. I don't know how many of you have seen with your own eyes. So PATA disk used to be there. Okay, PATA hard disks. Okay, so PATA hard disk used to be there. So which is parallel processing of the disk. So which those disks used to be like this. Okay, so this is a parallel port here you have. And so to connect to that, so you used to have this cable. Okay, so these big cables, parallel cables used to be there, parallel printers, and and parallel hard disks, parallel devices basically used to be there. If you look back 20 years back story, even 20 years, not 25 years around, if you look in. Okay, now slowly that has been changed by SATA. Okay, serial disks, by the way. When SATA came, by the way, so it reduces a lot of complexity, and even your cable becomes very slim and all also. So this is what you will see today, even if you have a um, laptop, sorry, desktop, by the way. You open the desktop, you'll see this laptop also, so more or less uses the same thing, but even much thinner cables, but the technology is still same. So serial disks, which is uh, okay, so serial is quite famous. Okay, there is PATA limitations, okay, parallel limitations, and why you need to go for serial. Okay, there is a hard disk theory, right? Whenever, maybe if you're not aware, maybe it's worth some time understanding some hardware things. So you just can read about it as well. Now, when these disks are coming into picture, okay, so then there was a terminology which is offered by operating system. So which it was like, when it was PATA disk, it used to be HDA, okay, hard disk A. Linux actually follows a terminology, hard disk A, okay, because you can have multiple disks. So that's HDA, HDB, HDC, like that it will come. Okay, then SATA came into picture. It is SDA, SDB, SDC. Okay, that will come into picture. Now here, okay, we are not using the physical servers, we are using a virtual machines, correct? Now, in virtual machine world, okay, so the names which are coming as, so LSBLK, if you can give, it is telling that NVMe, by the way, which is another type of hard disk, even on top of SATA. Okay, so there's another, disk coming into picture, which is nitrogen disks. No, what is that? Sorry, why nitrogen? Non-volatile memory express disk, so which is so famous disk, by the way, or so speed disk you can consider. Okay, so these disks are okay, very slim and very fast. Now this is the disk like Amazon is actually using and giving you. Okay, so that's how you're seeing this series name. Now if you look at it, I have one hard disk and I have created 4 partitions. This everyone knows that if you have a hard disk in Windows, you can cut into 4 pieces and you can do that. And also where you have is, so on the 4th partition, actually what we have done is we have created one logical partitions also. One big partition, we're taking some 19 GB. Okay. Now, rather than creating multiple partitions, what we're doing is we're doing a multiple logical partitions. Why we are doing a logical partition here is, so tomorrow, like let's say I am done with 20 GB, which is given. Let's say I added 0 N2 disk. So since it is a logical partition, what you can do is you can add your additional next disk also to the logical partition. You can map this logical partition, LVM, okay, to the next hard disk also, so that this logical partition can use the disk from first disk and second disk. Okay, it benefits you, by the way, an operation perspective. Okay, so if the disk is exhausted with the size, so you can add one more disk and you can add to the logical capacity. Beneath it is going to be 2 hard disk powering the thing, so it makes your life easy. So that's where generally in the Red Hat Linux, by the way, so we essentially go with the we essentially go with the logical partitions. Okay, and there is something called as okay, so CAS benchmarking. Okay, Center for Internet Excellence. Okay, so CIS, Center for Internet Excellence or Security, you can consider. So what it is actually tells is, okay, so it is a globally recognized, okay, conscious based best practices for securing your IT systems. Now, most of the IT systems you operate, okay, will adopt the CIS benchmarks. Now, in the CIS benchmark, okay, so what CIS benchmark is telling about, what CIS benchmark is telling about Red Hat Linux 9 hard disk Linux disks standards of using disk standards of using LVM. Okay, something like that. I'm just putting an open question. So what is CIS is telling about it? The CIS is telling you that, okay, so the logical partition of the data rather than the specific underlying storage, it strongly recommend using LVM to achieve certain standards. Okay, so what are those standards? Some standards are there. Okay, I'm as of now not much interested, but okay, to tell you at this moment, by the way, but there are certain, okay, benefits that help you in operating perspective, that benefits certain things on the security perspective of using these logical partitions. Okay, now CS benchmarks is usually open for anyone to download and use it. Now this image what we are using is okay, so CS benchmark 1, and that's where so different logical volumes are coming into picture. Whereas if you go and take a default, let's say if you go to the launch instance, and here, okay, if you take a Red Hat Linux, let's say, they may not give you the, so the CS benchmarking imaging. Okay, they give you the base one and expect you to go and configure what is necessary, right? So that is essentially someone has to do it. Okay, or else you can directly, if you are actually trying to buy a product, so you can go for, like, let's say CIS, you can search for that, you can directly get the, okay, so CIS hardened images directly, you can use them also. Okay, so by having this, you achieve the security. So just stepping back, by the way, so now coming to the disk, by the way, so you have a hard disk, NVMe N0 N1 is the formatting, NVMe 0N is the disk name, by the way. And inside that disk, you have P1, P2, P3, P4, which is partitions. And the last partition, so the other three partitions are for the OS perspective, booting perspective. Okay, but was the last partition, okay, which is coming up is the logical partitions required in the operating system. So those are being created logical partitions with certain advantages coming in for future perspective. So now this is the disk layout, and what all the systems which are, what all the mounts which are getting currently used and in use, by the way, you can see it out by using df-h, and also this tells you the logical disk, how much is the size, how much is used, how much is available. Okay, so this is what it is telling, so how much percentage it is used. And along with that, so there's also one more command. If you have any directory, like let's say varlog is there, varlog here, it is telling that, so it used is 101 MB. Okay, you can also get that information by using sudo, sorry, you can, here this point is different. So here you can get it is, so df-h of particular one also you want to get it. Yes, you can get that. So df-h of /varlog, it will tell you that information, only that information. And I think it's even df, not df-h. So now there is another command called as du-sh of that particular directory. So this requires sudo if I'm not wrong. So sudo df, sudo not df, du, disk usage of that one. You can see this here, it is telling you 101 MB is used, but actually really looking, so the actual size on the hard disk is used is 55 MB. So that covers certain other things also, like metadata and things like that is there. So that information also been covered here. but otherwise it is 55 MB is the actual usage on the disk. Okay, if you have any directory now, let's say it's not a mount point, but you wanted to know that what is the size of the directory, then do-sh is the command, so that will help you in helping you getting that information, the size. Okay, so overall, to give you the idea on the disk, by the way, on the operating system, lsblk is to get you the disk layout and what are the mounted file systems you can get it. And if you have a directory, okay, by the way, if you want to see the actual size of that directory, you can go with by using du-sh and that directory, so that you can get the size, actual disk consumed size of that particular disk, by the way. Okay, I think later you'll get some concepts of you'll get into a problem of where you require a more storage. How do you add more storage? You will face the problems. We'll see when the problems comes. We'll see that. Okay, but otherwise, this is what I wanted to talk about on the disk, by the way. So that's what I have here. Any questions on this? Any questions, confusions? Okay, cool. So that was the actual plan topic for today. But anyhow, since you're not asking much questions and I have enough time, so I'll go with the next topic also. Okay, so which is network understanding. Okay, networking, the very, very important thing in the microservices world is in the microservices world is the network part. So network is so complicated. Okay, network is so complicated. Because I already, I'm not sure, did I show the diagram? Netflix versus Amazon microservices. If you get on to, sorry, images. So this is how the diagrams will come into picture, the microservices graphs. Okay, so the microservice is nothing but the project has multiple services. So now let's say going to big companies, by the way, you try to run the services, and this is how the diagrams will come into picture. Okay, the platform diagrams. Now each and every dot represents a service talking to other service with a line. So it's a complicated diagrams coming in, right? So that's where um, so that's where the networking is so complicated, so architecture in the whole microservices world. Okay, and within the operating system, at least you should start understanding, so what is the complexity which is involved, by the way. All right, so that's where okay, so that is where I wanted to start here, which is with the networking. And so let's understand this networking, okay, in the Amazon perspective. Or let's understand the Amazon perspective from the home perspective. So we have a home, by the way, and in our home, how do you take the internet thing? Okay. So basically, what do? You will go to the ISP provider. You take an internet connection, correct? And after taking internet connection, internet connection, so what do? You will put it to your Wi-Fi router or something. Okay. So then the ISP provides one connection and some bandwidth to you. and you will buy a Wi-Fi router or even a wired router, doesn't matter. So then you will put to that internet connection, and then you put your multiple devices to the uh, Wi-Fi network, so that you'll split and use it. Okay, so this is what it is. So from internet, you're taking an ISP connection, and from there you'll put it to your router, and you connect your multiple devices. Now, but what is internet, by the way? Internet is nothing but a group of devices connected each other. That means, like, a lot of devices are there, and all the devices network is called as the internet only. So typically, okay, so if you look in each and every device, in order to plug into the network, you require a separate internet connection. Okay, but however, what we're doing is, see, but to the outside world, all your 4 devices is one internet connection only. It is never look like 4 devices. To the outside world, it always be a single device only. Your Wi-Fi router itself will go as a device. It won't be multiple internet connections. Okay, just for utilizing purpose, you are splitting the things. Now this is how the internet works, right? Now that means you are taking one connection and giving it to multiple servers. But now, okay, look at the companies also operates the same thing. Okay, now the internet is a large global network consisting of all the devices connected together. Your servers, laptops, mobiles, everything so interconnected. Where even that actually the list of servers, like you can have google.com, something.com. Okay, your device is part of that internet. All devices connected together, that network is nothing but a internet. While your home, which is connected internally, by the way, that is intranet. Okay, certain terminology here. Correct? Okay, and now taking one internet connection and so distributing to multiple devices, okay, is basically a NATing device, network address translation. Network address translation. So if I look in, okay, for an example, if I go to my system settings, if I look at my Wi-Fi, and if I look at the details, so you can see this, my IP address is 192.168.1.39. Okay, but I'll ask my browser, hey, what is my IP address? I mean, then what it will do is, what is my IP address? Now, this ipaddress.com will try to, okay, pull my actual IP address in the internet, by the way. My internet IP address is 49.205.254.22. So this is the actual internet address I have, that this address has been given to my Wi-Fi router, and from my Wi-Fi router, I connected to my device, by the way. But internally, these are all intranet. But even if I open my mobile, if I connect it to the same internet, so if I try to type the same, what is my IP address, it gives me the same address only, because to the outside world, every device of yours looks like the same only. Okay, correct. Now, what is the Wi-Fi router is doing here? It is actually translating your address from one address to another address. It's a NATing device. It does NATing from one device to, or one IP address to another IP address. The device is NATing device. Now, this is something. My IP address is something, but I might see something this one, right? So inside your home, this is the one. Outside the home, that is the one. Now just assume, so the network translates address your Wi-Fi router. This is okay. Okay. Now how Amazon actually mirrors this concept, by the way. Amazon also, when Amazon acts as a ISP provider, for an example, you take this IP address. What is my IP address is giving you our IP address only, but you can search other IPs also here. So this IP address, if I search for it, it tells that, okay, this is who is the ISP provider? Amazon. Amazon is also ISP provider, but he gives internet only to his data centers rather than relying on the third party. He himself is a ISP, internet provider. Okay, He also hold IPs and he have some bandwidth. So he just offers to this because he also in the infra business, he offers servers, he offers internet data centers and all, right? So that's where he has. So now if you look at the replication, by the way, now the same thing is also having a Amazon natting pool is there, which is Amazon natting devices, and the large set of public IP addresses will be there. Now, when you launch an EC2 instance, you have a private IP address for internal communication. Here. So now when I launch a server, by the way, so here I have a public IP address, okay? But there's also a private IP address. So this is a natting it is doing. So Amazon is doing a natting. Amazon is doing a natting in such a way that telling that if anyone reaches to this one, okay, so go to this particular server. So it is doing 1:1 ratio. In our home, we are taking one Wi-Fi router connecting to multiple devices. But Amazon over here is doing what? You're taking one public, by the way, to one private server. Okay, one public IP translating to one private IP is what it is doing. Okay, because they need to plug this one into the internet, they essentially have to do that. Okay, so but in companies we don't do that. So we'll not go in that approach in the public. Okay, in the companies, whether we'll talk about that bit later. But just as of now, let's understand the ground. Now you understand what is a public IP and private IP, by the way. So private IP address is for internal communication. Private IP address is for public communication. Now I'm outside of the public of Amazon network. Okay, so then what I had to do, I had to access it with a public IP address. I'm accessing my server with the public IP address. Whereas if I'm in the network, like let's say my private network is basically a company corporate network. If I dial some VPN or something like that, I enter into a company network, and then directly with the private IP address, I can access this server. Okay, anyhow, one day we will get into a problem of servers should not be exposed to public. You should have only private IP. How do you achieve? So one day the topic is already there, it will come. Okay, but until then, now what is the concept that you need to understand? So Amazon is a service provider. It offers 1:1 ratio as of now. Or as of now, we are taking an approach of 1:1. So they offer one public IP that translates to the private IP. Okay. So that's where when we actually try to access from the laptop, so we use public IP address. But internally, the instance to instance communication. So now after these topics, Linux, by the way, we'll start a project. So where multiple instances come into picture. Now you connect each and every server internally with a private IP address. Okay. Is okay. Now that's where the private IP versus public IP concept. Now, if you look at the server also, okay, so public IP will enable you the access from the internet and also gives you the internet. To my server, if I give ping google.com, so that I am going to get some internet. Ping google.com, so that means Google is reachable to me or not. Okay, so I'm getting it. Okay, so let's ask this question also to some GPT, by the way. Then what it will tell you, listen. Okay, so then so you can see this. So in cloud while learning, I have access to google.com. But in my company, server of same AWS instance is not having it. And in fact, I don't have internet. Servers. Okay, just as a reading perspective, let's put this question. Something went wrong. Okay, so that's the enterprise reality graph right there. In a lab, you're a king of a gateway where you're behind a big fortress kind of a thing, right? Since your company server is dark, like follows say like ACS, network configuration, things like that. Okay, so basically like overall how to survive without an internet. So just give me So basically, like, so why company server is dark? Okay. So, I mean, or no internet, by the way, isn't a bug kind of a thing. Okay. So you is a standard. You work with if you go into enterprise company, you will not have internet and all. Okay. Anyhow, this is not actually giving the information. Maybe my prompting is wrong. Okay. But all I wanted to tell is, okay. So having no internet in servers is the enterprise reality. Okay, just ask that question. The answer is your enterprise, world, and open server is considered a liability, not a luxury. Okay, having no direct access is a foundational security posture. So that's where, okay, so one day we'll think about, how do you reach there, but day one will not think about that. Okay, so security is the last topics that we'll cover. Okay, where we'll change the landscape of our whole infra. Okay, so that is where until then it is just let's keep the let's keep the basic lab approach only. Okay, one day we'll get into that area. Now the public IP enables you to get access from the internet and also gives you the internet also. It's not only that you access from the internet, it also gives you the internet also. Correct. And that's where it is. And verifying your network information. So private IP is the actual IP address of the server. Like, I already shown the system settings from here. My 192.168.1.39 is the actual IP address of my machine, but it is getting translated by Wi-Fi router, which is a NATing device. Even the reality in the same in the server also. My server is actually going to have an IP address, which is 172.13.1.12.217, which is also the same thing that will show from the UI as well. Okay, so it is going to be the same one, and this is the actual IP address. Okay. And so this is getting NATed to another device. And another device, whoever hits that device, that is translating the traffic to the server. So this is how it is happening. So you can execute a command IP-A to know the real IP of the server. So this is the actual IP address of the server. IP-A is the command that we'll use to get the IP address. And where you can see that, two things here, LO, which determines, there's a little bit internals. Whenever you get some time, you can read it about it. So determine the IP address of the referring to the same system. Okay. Even you put a network cable or you don't put the network cable. Let's say I have a standalone server. I have a desktop, let's say. I have a laptop, let's say. Laptop can still power on even without an internet also. Correct. So that means I didn't connect it to the internet, but still I can open the laptop. Okay. I can do something, right? So the server also the same thing. Okay. So without connection also, it should start. But to start, by the way, so you have seen certain programs actually, require, when we created a sample.service file, so you have seen the network.target. So that means the network is very important to start for the remaining services also to start. This is by design, by the way. Okay. So the network need to be started in order to start my other services. Okay, because other services serve on the network. Even I don't put the network cable or connect to my Wi-Fi, by the way. So servers need to still power up, by the way. So for that, okay, at least an internal network need to be powered on. Okay, for that there is a loopback address comes into picture. The same loopback is applicable to your Windows, my Mac OS, everywhere it is applicable, by the way. Okay, Windows also it is the same thing. And it is a standard address, which is 127.0.0.1, which we also called as a local host. So here loopback, we call it. Okay, because every operating system designed in such a way that to start the services network is essential. And if a network is a failure, none of the services will start up. But that's not the case that we generally. So even though without the network, at least I need to power on the machine, start the services. They may not serve, by the way. That's okay. They may not serve, but still need to start. So that's where a local address, local network comes into picture. And you can also find your so public IP address, like how I went with what is my IP address. In the server also, I can do the same thing. Curl if config.me, it gives me an IP address. So 32.192.3.146, which is the same IP address coming here also, right? Okay, so that's how it is. Okay, so now overall, how do you reach your your server is, you have a public IP address, you hit the public IP, and Amazon has a natting pool, natting devices that translates, okay, this is the request coming in. Okay, I have given to this so and so customer. Okay, let me route the traffic to that guy. Okay, that how it is reaching out to you. So that is how it is going to be. So the networking, overall, with all this explanation, what I want you to understand is how do you know your IP address of the system? So usually when you go with the normal prompting, by the way, not a customized prompt, you can get only the IP address by using IP-A. But what I have done here is I have done a customized prompt immediately without. So because we deal with the networking all the time, network. So microservices means network. So that's where I have given a prompt allowed on the top, by the way, which gives me what is my public IP, what is my private IP here itself, and even the instance type also what I'm using. At a short, I'll come to know what is my infra. So I don't need to really go to the Amazon console and do that and all. Okay, so it helps me a little bit. So that is the reason we are doing this, or I have done this. Okay, so I usually do this even in my private servers also. At least on the top, I'll give my IP address so that I'll come to know that. So this is my IP address. Essentially, so this avoids doing some mistakes also. Okay. Usually I'll work on multiple prompts. Okay. While I'm working on multiple prompts, a command that I type, I mistakenly I can execute on another server also. That can impact. Okay. Just to avoid that, I always started my consciousness, okay, to just have a double check, by the way, by looking at the IP address once again. Okay. So that's where I always put an IP address, even in the servers where I work or where I build. By the way, usually I'll customize the prompt, okay, to have my productivity better. So that's where I always keep the IP address, and it's a customizable prompt. I already tell you, right? So that is how it is. Now, overall, how do you check your IP address? IP space a command is what you will do. Clear? Any questions? Public private natting.
Yeah, hi, hello.
Yes.
Hello. Actually, I internet service provider to internet came to router na. So sometimes internet is not working. So how can we troubleshoot? Where is the issue? So is there any the?
Internet not working is a non-reality scenario of the world
Mm,
that applies to your home, not to the data centers. And also, it's not your job, right? What do you do? Internet is not coming to the data center. You can't do anything. The data center provider or a data
we
center
can check.
main.
We can check. How can we check where is the issue? Is there any?
And first of all, we are talking about no internet world, right? If no internet is coming, why do you need to troubleshoot? You get into a company, what I'm stressing and I shown you from the internet is no internet is a reality, whether then what do you need to troubleshoot? That way also your question is not valid. Nah? You're not audible.
Okay, understand.
Hey, hi Raghu.
Yeah.
Yeah, Raghu, one quick question. This NAT IP, in case of any enterprise application, so if you want to expand, assume that when we are having an enterprise for the e-commerce system, but where we want to have more traffic is expected. So in that case, do we need to explicitly increase the NAT IPs to handle it, or AWS take care?
So NAT IPs, because you will not use those when that's what is a later once you get into a real reality, you will never have a public IP at all. It's all going to be a private IPs.
Okay.
Okay, which in where and this natting will not come into picture. So typically any company will have one entry point. Okay. So later we'll talk about AWS landing zone and all. So landing zone will have some network. I'm not sure you heard about it, but something called as AWS landing zone is there. So in the landing zone, so you'll have a network zone also. So where the entry point to your company is one .com only. Okay. Now let's say Amazon.com or AWS you're using, right? Amazon.com, AWS.com. It is one IP only all the time. You will not have
Okay.
scalable multiple IPs. It's going to be entry point is always one. And that entry point scalability, yes, your point is right. So it will be taken care by the service providers.
Okay. 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 Yeah, sure. Thank you.
Yeah. You're not audible. You're not audible. Moving on. So that comes to the one of the last topic I wanted to cover. Now you should get a question that, hey, my server is publicly exposed. How safe I am? Something like that, right? So usually, um, so that is where, okay. So generally, all your servers are usually being protected, and that protection comes is called as firewall. Okay, firewall is a device. Okay, so firewall. Let's say there are famous devices. Okay, so who are famous in the firewalls is if one is F5 will come. Okay, FortiGate is there, Palo Alto is there, Cisco. Okay, I'm talking about not load balancer. Yeah, Palo Alto is one of the very famous firewall provider, and along with that Cisco have it, Checkpoint have it. Okay, I think these two are Israel based, so it's so famous for the security perspective. Now, or these two are Israel based. I don't know. At least Palo Alto is Israel based. Okay, so and yeah, and why I'm telling Israel is because Israel is known for its security. Okay, at least that country itself is known for its own, I mean, devices that makes security devices. So that's why I'm stressing. Okay, yeah. Coming back, so you have some devices by the way. So in company, I will have certain device. For an example like this. Okay. So like these devices will be there. So the device will buy the device and we'll keep it in our own data centers. Now Amazon provides this as a service. Okay. Or which is like, so this is typically a hardware level. So they virtualize it and keep it some sort of a software level we can consider as either it can be a software level firewall. That's okay. But there's a firewall. Firewall is a device. Firewall is a device that between your server and your outside network that controls the network traffic, which to block like who is allowed, who is not allowed. It's like a security guard. It's like a security guard who is who is standing before to the building. So who looks like whether you are allowed or not allowed to enter into the building. It's as simple as that. Firewall is a security guard only. Okay. Now what is the traffic coming from? So where is the traffic coming from? What is the IP address? Okay. And where it is going. So that means like where is my destination? Where it is going? Okay, so it will look into that. And what kind of traffic it is, what kind of traffic it is, kind of traffic. Okay, this will maybe today's time not enough. Later session we'll talk about it. But yeah, what kind of traffic it is, it looks in that. And also it can, how often it happens. I don't think so how happen is actually need to be part of this guy. You can remove this, it's okay. So what kind of traffic is what it looks in. Now, on top of this, by looking at what is the source destination and what kind of traffic, then I should allow or not, it will decide by the way. So it depends upon the rules which is configured. Let's say if I have a web server traffic, so which is running on 80 and 443, something like that. So what is this numbers? We'll see that in the next session. So if I need to allow, it will allow. Whereas SSH, it should be allowed only from the office IP, whereas everything else need to be blocked. So it can be blocked. So only like, whoever is accessing my application over the web browser, because it's a web application, web browser or mobile app. So I should allow it from anywhere. Whoever is trying to access my server, SSH by the way, so it should be allowed only from Office IP, and everything else need to be blocked. Okay, this kind of a rule you can write it. Now, by writing that particular rule, then what your firewall will do is will look for those particular details, who is coming in, who is going, I mean, where it is going, and what kind of traffic it is coming in. So it can determine whether to allow or not allow. In Amazon, usually the servers are protected by firewalls. Every server is protected by a firewall, which controls the incoming and outgoing traffic. In AWS, these firewall rules are implemented through security groups. Security group is a configuration of your firewall. Okay, now each and every device, okay, should be must and having one security group. By the way, we have not created it so far, so that automatically when you actually launch it, so when you're since you're launching a EC2 instance, Amazon is actually thinking that okay, this guy needs to access the server from the outside world. So that's where what he has telling is, so anyone coming from internet, like so the 000 means the full internet. We talk about it. The full internet can reach over 22, which is SSH port, is allowed, is what we have written. The full internet should be able to reach to my 22 port, is what is the rule, which automatically opened when I am launching an instance. Since I did not give any firewall security group, it is not interrupting you. It is giving you the rule automatically, understanding this is a Linux box and I need to open 22. It is doing that particular job. Okay. And having said that, when you actually launch an instance, so ideally, I can also choose my own security group as well. You can create one security group and you can go for that. So you can come to the network settings, you can choose a security group and you can choose whichever the security group you want. Okay, so security groups is a network network security layer that allows and blocks the traffic. In AWS, inbound rules, which is nothing but incoming, okay, to determine, in AWS, inbound specifies what kind of traffic can reach your instance. So when you actually go to this instance, there's a inbound traffic, there's a outbound traffic. Same like security guard. So who is coming in, he validates it. Who is going out also, they will validate, right? Maybe let's say in some scenarios, let's say you are in society, like let's say in some gated society, the security guard will look for even who is going out also. Okay, they will check the people who is going out of, if someone came and doing some theft. Okay, so outgoing traffic also you need to monitor. So that criteria also will come into picture, some scenarios. So that's where outbound rules, where my server is reaching, inbound rules, who is reaching my server. Okay, that is what inbound and outbound we call it up. And yeah, so in each server, every server is protected by a security group, and a single security group can protect all the servers as well. And each server can have one or more security groups also. Just try to understand this logic. Every server will be protected by a security group. One security group only can be used for all your instances, and each instance can have multiple security groups also. You can do that. It's all about your organizing. So that's how we are going to have security groups. And so maybe in next session, we'll talk about how do we how to create a security group, and from there, the instances which we are creating, um, what are you creating? So we'll attach our own security group. And also we'll start talking about certain ports and services in your operating system. Okay, so what are these? And we'll talk about that in the next session. And we'll proceed from there into the project area, by the way. So we'll learn some commands, and using those commands, we'll start implementing the things. Okay, once we understand certain networking things, we'll get onto a project, start the project, mostly from the next session itself. So that will be after 2 days, which is Monday for Indian folks, it is Sunday evening for USA folks. That's all from my side for today. Any questions, please go ahead. If you don't have any questions, feel free to drop. Thank you. Good day.
Hey, Raghu, can we go over the two sections of that IP address in Linux?
Yeah.
Yeah, these two.
Yes. Anyhow, here is a screenshot.
I guess what's the difference between the two?
One is your Wi-Fi. In order to connect to your Wi-Fi router, you know that there's a Wi-Fi device in your laptop or mobile. Correct?
Yeah.
So this is a server, usually will not be on the Wi-Fi. So they'll be having a network adapter. Let's say you step back 2 years back, your laptop, maybe Wi-Fi is not there. You put a cable, correct? There's an interface.
Mm-hmm.
That interface is this one, EN5.
Oh, okay. Okay, that's that.
Yeah.
Okay.
Yeah. By design, actually, the operating system is designed to have a minimum networking start so that only the other services can start. Okay. If you put a cable, the customer will access it. If you don't put the cable, the server can still be started up. Okay. That means network becomes an essential core of your operating system and other services also to start, by the way. That's by design, the OS design, by the way. So not only to the Linux, every operating system also. So that's where they come up with the one address, which is actually a local address. This can't be servable to outside world. Is only for the server. Even though you don't have any network, server can still power up and power on. Boot, by the way. To have the bootable success, they came up with the loopback address. That is one device you'll find out in every operating system, including my MacBook also. For an example here, IP command one day if configure. Yeah. So here my Wi-Fi router will be something. So here you have still my loopback, right? So there are some virtual networks in my system for maybe containers or blah 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 created. So but this is my EN0 interface.
So that's the one where our public, that's the front-facing IP in EN0.
I'm not taking the
and
cable from internet putting to my laptop directly. If I do that, you will see public IP only here. But that's not what I'm taking the cable from internet, putting to my Wi-Fi router. My Wi-Fi router is actually splitting the traffic. That means I get a Wi-Fi router IP address. This is my Wi-Fi router given IP address.
Yeah, Wi-Fi. Yeah. Okay. All right. Thank you.
Yeah. Any other questions? Okay. All right. So then we'll meet in next session. We'll continue from there.